welcome to our next lesson for Science for Healthcare Workers. We are moving on to the metric system and doing conversions. And the takeaway from today is the metric system. It's pretty cool. Are you ready, ladies? So when we measure things, because that's what we're talking about measuring things. We have three different ways we can measure things, the objects, the world around us. How do we measure them? What do we see in these pictures? What's the first one? When we talk about like social distancing at 6 feet, what are we measuring? What is 6 feet? Space, yep. And distance is the word I'm really looking for, but that distance, right? That space between two spaces, right? That space in between, the distance of them. Here we're pouring water into a graduated cylinder. What are we measuring here? We're measuring the amount of liquid, the volume. Very good. We can look at volume, which again is kind of space, but it's three-dimensional, right? That it's everything that fits inside that area, the volume. And then here I'm looking at how much those two eggs weigh. And what am I looking there?
Weight.
Weight, or the scientific word for weight is mass. These are almost the same thing, almost. The difference between them is very, very scientific. Does anyone know the difference between weight and mass? Oh, any guesses about the difference between weight and mass?
Can you have like the weight, like the mass talks about how big it is versus weight, but talks about maybe the weight. I don't know.
Well, that's a good guess, Libby. You're thinking about it. All right. All right. I will give you a scenario. So weight and mass are they're connected to each other. We use weight to describe mass. For example, I take this cup here and I can weigh it and I can say, wow, this cup is 2 pounds. It has 2 pounds of mass. But if I took this coffee cup and I went to the moon, would it weigh the same?
No.
No. If I took it to Mars, would it weigh the same?
Probably not.
Nope, because the gravitational pull is different, but it has the same amount of mass. So the cup hasn't changed. It has the same amount of mass. Weight is affected because of the gravitational pull. So weight is really the reaction of gravity. So I can take this mass and say, oh, because of gravity here on Earth, it now weighs 2 pounds, or it weighs 32 ounces because of gravity. So here on Earth, weight and mass are pretty much the same exact thing because we use mass to determine the weight because of gravity. But scientists look at weight and mass differently because if we took an object here on Earth and moved it somewhere else, we know that it would weigh different based on gravitational pulls. And that's why like you could go into space and it's in theory weightless. There is no weight because there is no gravitational force pulling on it. So weight and mass are pretty much the same thing, but they are different if you really slice the science. But here on Earth and in hospitals, because we're not going to talk about space stations or hospitals on Mars, just hospitals here on Earth, weight and mass are the same thing. So it's the other thing we can measure. How much does something weigh or how much does someone weigh? We're going to look at these three things. Let's first focus on distance. So we can look at the distance of this room. Now, when we measure distance, we have to come up with a unit of measurement. So we come up with a standard saying, all right, this is what we use to measure things, and we're going to measure how many of them fit in this space. So how many of these red boxes fit into this space?
5.
5. So it's 5 units of red going all the way across. Now I have another unit that's a little bit smaller to help me measure smaller things, which are blue. And 10 of these blue boxes can fit into one red box. So how many blue boxes would go across this entire room?
50.
50, yep. So there's 10 for each of these boxes. Now I have an even smaller one. If I want to measure really, really, really small things, I have this black one. And there are 10 of these black boxes that fit into each of those blue boxes. So we have 10, 10, 10, 10. How many of these black boxes would fit across the room?
500?
500. Pretty easy, right? 5, 50, 500. Simple.
Yeah.
This is how the metric system works. The metric system is in units of 10. So there's like meters, there's millimeters, there's centimeters, and everything is in groups of 10. Let's look at our system, the standard system. So again, we have this big unit, and there's 5 of them that fit across. But now we have this smaller unit, that's our blue boxes, and we have 3 of them that fit into a red box. How many blue boxes would fit across this room?
15?
Ooh, harder math. We can still do it, but it's a little bit harder math, right? 15. All right, now we have this small one for really, really small things, but now 12 of them. 12 of these fit into one blue box. How many of the black boxes would fit all the way across this room?
12 times 15?
12 times 15. What is 12 times 15?
I don't know.
All right, we're going to do some long division here. So I'm going to go 2 times 5 is 10. 2 times 1 is 2 plus 1 is 3. I'm going to move over 1 space. 1 times 5 is 5. 1 times 1 is 1, and then I'm going to add those together. 180. So there's 180 of these black boxes. Now, look how much more complicated that was. Because we have 1, 3, and 12. That's exactly how the standard system works. Right? The standard system is we have yards, we have feet, and there's 3 feet to every yard. And then we have inches, and there's 12 inches to every feet. Question, why do we do this? Why? And also it's called the standard system. Do you know how many countries use the standard system? The standard. How many countries?
All of them? All of them?
All but us.
No. Oh, so they use the metric system. So this is the metric system. Here's the metric system. And that's every country, pretty much every country in the world. This system here, the standard system is used in the United States of America and only the United. There are 3 countries in the world that do not use the metric system. 3. And we're one of them. Why? I don't know why we're doing this. So when we look at the metric system, it's pretty simple because it's all units of 10. So again, we have meters, which are that big unit of measurement. They have centimeters and they have millimeters. And then you can go up higher. So if you take 1,000 meters, that equals 1 kilometer. So it's all units of 10. So here's some questions for us. So again, if we went back here, so I have, so 5 meters would be 500 centimeters, which would be 5,000 millimeters. If we look at the standard system, how many feet are there in a mile? Do we know? How many yards are in a mile? How many inches are in a mile? Do we know those answers? Any guesses? Let's guess. If you had to do your best estimate, how many feet do you think there are in a mile? Any guesses?
Let's go with 5,000 feet.
Good, very close. It's a little bit more than 5,000. Any other guesses? It's more than 5,000.
7,000.
Oh, way too much. It is final answer is 5,280 feet in a mile. How many yards are in a mile? Remember, a yard is 3 feet, so it's going to be less. It's going to be about a third. So we're going to divide that by 3. How many yards are in a mile? Any guesses? We could actually just divide it by 3. If you take that and divide it by 3, you get 1,760 yards equals 1 mile. Now we have 12 inches in a foot. So if we take 5,280 and we multiply it by 12, that would give us our number of inches. And that is 63,360 inches. Now, I'm not that smart, ladies. I actually looked this up beforehand and I wrote it down on a little sticky note. So you're like, how is he doing that? I cheated because you have to with our system. But again, if we go back to the metric system, you don't, right? How simple is that metric system? So that's why the motto of today is it's really that simple. So we have 1 meter, right? That it's about this big. It's about 3 feet. So 1 meter of measurement. If we do 1,000 of those, that's 1 kilometer. So we have 1 kilometer, which is kind of like their miles, right? It's that really long distance. It's the distance you drive. You drive kilometers, right? Your house would be 5 kilometers, right? Where those are your large distances. 1 kilometer would be 1,000 meters. 1,000 meters, which would then be, if I add 2 more zeros, it would be that many centimeters. So it's 100,000 centimeters. Or if I add another 0, it would be 1 million millimeters. Those are all the same unit of measurement, right? It's the same distance. 1 million millimeters, 100,000 centimeters, 1,000 meters is 1 kilometer. So it's so easy to convert between them. So if we wanted to say, well, how far is 5.5 kilometers? Well, 5.5 kilometers is 5,500 meters, which would be 550,000 centimeters. See how easy that was? Or 5,500,000 millimeters. Easy. Easy peasy. Does that make sense?
Yes.
So much easier than
so much easier than our system, where you have to be like, all right, there's 12 inches in a foot, there's 3 feet in a yard, like, because since their system is all based on tens, you just have to move the decimal point and add zeros, right? Like it's so easy to do math that way. So that's distance.
I did
Pretty
notice that
simple. Now we're going to move.
I did notice that
Go ahead,
Americans are not flexible when it comes to the metric system, when it should be the other way around.
Yeah, it should be, absolutely, because the metric system is so easy. But change is hard. I mean, if you grow up with one perspective, even if your perspective is kind of wonky and crazy, it's hard to change your perspective.
But
And so
it's easier for a Canadian to adapt to the American metric system than for American to adapt to the Canadian. I noticed.
Oh, interesting. Okay. Maybe it's because Americans are just so stubborn that they're like, we're not going to change. And the Canadians are like, and the Canadians are just like, okay, well.
Are we doing geometry today? Okay.
Yeah. All right, moving on to volume. So this is what makes volume very interesting. Volume is really similar to distance. The only difference is it's 3-dimensional, right? That volume is really, we're taking the distance of a 3-dimensional shape. We have our length of our object, our width of our object, and our height of the object. And if we calculate those little cubes, that then gives us our volume. Our volume is just looking at distance 3-dimensionally. So like here, I made a perfect cube. I have 10 centimeters by 10 centimeters by 10 centimeters, which is 1,000 cubic centimeters, right? And so it looks like this. There'd be 1,000 of those little cubes. If I made a cube, a box that was 10 centimeters by 10 centimeters by 10 centimeters, it would be exactly 1 liter of water. 1 liter of liquid, because the metric system, not only is it beautiful and perfect and measurements of 10, they're also connected to each other. You take those centimeters to make your volume of liter. So 1,000 cubic centimeters is the same thing as 1 liter, or 1,000 milliliters. And in the hospital, this was one of our abbreviations, cc's, which are cubic centimeters, which is one of these little cubes. That's how we measure injections in hospitals, right? It'll be 2 cc's or 3 cc's or 0.5 cc's. It's 1 centimeter by 1 centimeter by 1 centimeter of volume. And that's what fits inside one of those syringes for injections. Does that make sense?
Yes.
And again, we can convert really easily. That 1 liter is 1,000 milliliters. If you go to the grocery store and you buy a bottle of whiskey that's 750 milliliters, that means it's 0.75 liters, or about 3/4 of a liter. Right? Easy peasy. Pretty simple.
Yeah, it's actually easier to understand.
Yeah, it's easier to understand. Now let's look at our system, the standards. Oh, no, here's a math problem. So if I have 3 liters, so if I buy a 3-liter bottle of Coca-Cola, how many milliliters would that be? Because here's my liter. So I have 1, 2, and 3 of them. Each of these is 1,000 of those cubic centimeters or millimeters. So there'd be 3,000 milliliters, or 3,000 cubic centimeters. Sorry, that's a typo here. That should be cc's, cubic centimeters. 1 centimeter by 1 centimeter by 1 centimeter. So again, we just move the decimal place over. Now, if we look at our system, the standard system here, we use all these different units of measurements. We have fluid ounces, we have cups, we have pints, quarts, and gallons. Now, how much is each? Let's start with fluid ounces. How many fluid ounces is in 1 cup? Do we know?
8.
Boom, 8 fluid ounces in 1 cup. Good work. Now, how many cups are in a pint?
2 cups.
2 cups is in 1 pint. How many pints are in a quart?
2.
2 pints are in 1 quart. And how many quart is in a gallon?
4.
4 quarts in a gallon. But again, why do we do this to ourselves, ladies? Look how complicated this has to be, because they're all just like odd numbers. Actually, they're all even numbers, 8, 2, 2, and 4. But still, like, it's not as easy as just making everything units of 10, right? Where you can just literally move the decimal place over because everything is divisible by 10. Here we actually have to know. And this is where, when you are working in a hospital and you're having to measure the intake of patients, so how much liquid is a patient taking in, you have to be aware of all of these units of measurement, because you may give them a pint of ice cream, but then you'll give them 2 cups of soup. Or, you know what I mean? So you're mixing these different units of measurements, and you have to then convert so you can have a grand total of how much liquid altogether is that patient taking into their body. And then when they go to the bathroom, you have to measure how much their outtake is. How much are they urinating and peeing? And that graduated cylinder in the bathroom is going to be in milliliters. So you have to measure what they're taking in from the kitchen, from all of the food and drink that they're taking in, and then convert that to milliliters. And then you have to use the graduated cylinder in the bathroom to measure how many milliliters they're urinating. So there is a lot of math that has to go on. Luckily, in the hospital, they will give you these charts. So you know a cup is how many pints and a pint is how many gallons. They will give you this chart that you won't have to have this memorized, but you will have to know how to use the math of how do we convert between these two. And that's what we're going to practice today, is using these different units of measurement of volume and how do we add them all together under 1 unit. All right, so we have a gallon of milk. How many quarts are in a gallon of milk?
4.
4. Now, how many pints are in a gallon of milk? Ooh. Well, we know that 2 pints
7,
equals
8.
1 quart, and we know that there are going to be 4 quarts in a gallon. So how many pints are up there? We have 2 times 4. So what I'm going to do is what's called cross multiplication. So I'm going to take this number and I'm going to multiply it by that number, and then I'm going to divide it by that number. So 2 times 4 is 8, divided by 1 is still 8. So there is 8 pints to a gallon. Now, how many cups are in a gallon? Well, I know there's 2 cups for 1 pint. So I have 2 cups and I have 1 pint. We have a total of 8 pints so far, 8 pints, and we want to know how many cups that is. How many cups is 8 pint? I'm going to cross multiply again. So I'm going to take my 2, multiply by my 8. What is 2 times 8?
16.
16. 16 divided by 1
16.
is 16. So I know it'll be 16 cups. And so a gallon has 16 cups in it. Now, how many fluid ounces is that? How many fluid ounces is 16 cups? Well, I know 8 ounces is 1 cup, and I have 16 cups. How many fluid ounces is 16 cups? I'm going to cross multiply. So 8 times 16. What is 8 times 16?
128.
128. I trust you on this one. My brain melted. I couldn't do that in my head. I'd have to write it out this way. So I'd go 8 times 16. 8 times 6 is 48. Carry the 4 over here. 8 times 1 is 8. 9, 10, 11, 12. 128. I agree. 128 divided by 1 is going to be the same thing. So we have 128 fluid ounces in a gallon. So that is the math that you're going to have to be able to do. If you're doing it with paper and pencil with a calculator, it's called cross multiplication, where you take the number on top and you're going to multiply it by the number on the bottom, and then you divide by that following number. Cross multiplication. All right. Let's practice again. We have 3 gallons of milk. How many quarts is 3 gallons of milk? All right, so I know 4 quarts equals 1 gallon, and we're trying to do 3 gallons. How many quarts is 3 gallons?
12.
Yep, 4 times 3 is 12. We got 12 quarts. All right, let's do the next one. We got 12 quarts. How many pints? Well, I know it's 2 pints to 1 quart, so 2 pints equals 1 quart. And I have 12 quarts. How many pints is 12 quarts? I'm going to cross multiply. What do we got? 24. 2 times 12 is 24. All right, we got 24 pints. How many cups is 24 pints? So I have 2 cups equals 1 pint. I have a total of 24 pints so far, and I want to know how many cups is 24 pints. What do I got?
48.
48. And then here's our hard one, the big one. We have 8 ounces for 1 cup. So I have 8 ounces equals 1 cup. That's my ratio. And I know that I have 48 cups at the moment. Do I write 48 on the top or on the bottom? Where do I write 48? On the top, up here, or on the bottom, down here? Where do I write 48?
On the bottom.
top or bottom? On the bottom. And why do I write 48 on the bottom? Do we know why I'm writing it on the bottom? What? Because I want to keep that same unit of measurement on the bottom. So if the bottom is cups, the bottom is going to be cups. So then the top is ounces. The top over here is going to be ounces. And I want to know how many ounces are there. So I'm going to cross multiply 8 times 48. What is 8 times 48? Do we have a calculator, ladies? 48.
384.
Say it again, Libby.
I think it's 384 ounces. 384 ounces.
384. Well, I have 8 times 8 is 64. So we got the 4. And I put the 6 up here. 8 times 4 is 32, 33, 34, 35, 36, 37, 38. I agree. 384 ounces. 384 fluid ounces. All right, so that's cross multiplication, and that's what we're going to practice a lot of today. And when we do cross multiplication, we have two fractions. So we have our ratio, that 8 ounces is the same thing as 1 cup. And then over here, I'm putting my cup over here of 48 cups, which is the same thing as 384 fluid ounces. And we know mathematically I can cross multiply to find that answer. So if I didn't know 384, I know that if I take this number 8 and multiply it by 48 and divide by 1, that will give me 384. We can cross multiply. The reason why I'm dividing is because this is a 1, and so it works out being a 1. But if it wasn't a 1, I would need to divide by this bottom number. Dividing by 1 gives you the same answer, but if it wasn't 1, if we were saying like 2 ounces equaled like, well, yeah, let's do that. We're going to do 2 cups. So if I had 2 cups down here, and that would be 16 ounces, right? 16 ounces equals 2 cups. How much is 48 cups? To do this proportion, we would need to take 16 times 48 and then divide it by 2. What is 16 times 48? Who has a calculator?
768.
768. And if we take 768 and we divide it by 2, what do we get?
384.
384. So do you see how that works mathematically? So this rule is called cross multiplication, that if you multiply and then you divide by the thing that's left over. You cross multiply and then divide. Cross multiply and divide. It also works the other way around. Watch this. This is going to blow your mind, ladies. All right, so I have these numbers here. Let's say we didn't know 48 and we needed to know how many cups that is. That I know 16 ounces is 2 cups. And if I have 384 ounces, I want to know how many cups that is. Well, I'm going to cross multiply. I can take 2 times 384 and then divide it by 16. Let's do that. Who has a calculator? Let's do 2 times 384. What do we got? What is 2 times 384? It's going to be more than 600. It's going to be like
768.
758, is that what you said?
68.
68?
768.
768. So we have 768. Now let's divide by the last number, 16. We're going to divide that by 16. And what do we get?
48.
How many cups is that? It's 48. Isn't that cool how that works? So ratios and proportions always work this way, that if you multiply by the diagonal and then divide by that third number, you will get that other number on the bottom. So it's cross multiplication. And that's the skill we're going to work on today, is cross multiplication. All right, so going back to our system, When we were looking at the metric system, volume is connected to distance, right? We had 10 centimeters by 10 centimeters by 10 centimeters equal 1 liquid. Can we do that with our system, with the standard system in the United States? Do we know how many cubic inches is in a gallon? So if we took 12 inches by 12 inches by 12 inches, so it would be 1 foot by 1 foot by 1 foot, is that a gallon of water? No. Absolutely not. So how many of these cubic inches is in a gallon? Is there an easy way to measure that? Do we know? What's your gut instinct? Is that a yes or a no answer?
I'm gonna go with a no.
It is a big no. There's 231, an odd number, of cubic inches inside a gallon. So if we wanted to make a perfect box and fill it up with water to be like, this is 1 gallon of water, that box would be 6.1357 inches by 6.1357 inches by 6.1357 inches, and that would be exactly 1 gallon of water. Again, why do we do this to ourselves when the metric system is so perfect? With the metric system, we could take 10 centimeters by 10 centimeters by 10 centimeters, and that makes 1 liter of liquid. And I know that's 1,000 milliliters or 1,000 cc's. It's perfect. The standard system is not. They are 3 units of measurement that are not connected to each other at all. So again, that metric system is so perfect and beautiful. 10 centimeters by 10 centimeters by 10 centimeters is 1 liter or 1,000 milliliters. All right, weight. Here's where your brain's really going to explode, ladies. Is your brain ready? Is your brain ready?
No.
No, it's going to explode. All right, so if we take that perfect cube, right, that 10 centimeters by 10 centimeters by 10 centimeters, and we fill it up with water, so it's 1 liter of water, guess how much that weighs if we put it on a scale here in the United States at 4 degrees Celsius? It weighs 1 kilogram.
Say
Did
what
you
number?
know that?
No, I did not.
Does that make sense? Do you understand what I'm saying?
It just sounds like it's gonna be easier to convert things.
Yeah, it's so much easier to convert things. And you see how they're connected to each other, right? That we have the distance. We have 10 centimeters, that distance. And if we make the volume 10 centimeters by 10 centimeters, we have this perfect cube and we fill it up with water. We now have a liter of water. And if we weighed it, it would weigh 1 kilogram of mass. 1 liter of water weighs 1 kilogram of weight because they're connected, right? You have milliliters and you have kilograms, which is weight, but they're the same. 1 liter of water is 1 kilogram of weight. So if you had 10 liters of water, how much does 10 liters of water weigh?
10 kilograms.
10 kilograms. If you have 10 gallons of milk, how much does that weigh? I have no idea, right? Because weight, the gallons of milk is not connected to our pounds. They're not connected to each other. The metric system was invented by scientists in Europe, and they're interconnected to each other, all divisible by 10. But the thing with this kilogram thing is there's a few factors. One, it has to be water because other liquids weigh differently, right? That soup, with like chunks of stuff in it would weigh different than soda that's carbonated, right? That it has to be H2O, and it also has to be 4 degrees Celsius. Because as we know with thermodynamics, as we change the temperature of something, it also changes the mass, which will change the weight. So as water heats up, it becomes lighter. As water cools down, it gets heavier. So it has to be very chilled, 4 degrees Celsius. It's like cold, refreshing drinking water. If we weighed exactly 1 liter of cold, refreshing drinking water, it would be 1 kilogram of weight, which is 1,000 grams or 1,000,000 milligrams. Because again, these units of measurements, the smaller bits are just divisible by 10. All right. Does that make sense? Are you staying with me? Am I going too fast? If something is not clear, please feel free to stop me and I will try to explain it a different way. Are we good?
So far, so good.
So far, so
Keep
good.
going.
So let's look at this problem. So I bought this 3 liter of Coke, 3 liters, right? So it's 10 centimeters by 10 centimeters by 10 centimeters, and I have 3 of those. So it's 3 liters or 3,000 milliliters or 3,000 cc's. And if I weighed it, it's going to be a little less than 3 kilograms because Coca-Cola is carbonated. But if it was water, it would be pretty much exactly 3 kilograms of weight, which is 3,000 grams, which is the same thing as 3,000 cc's, which are those measures of injections, right? So if you're giving someone 1 cc and you did it 3,000 times, it would be the same thing as 3 liters of Coca-Cola because they're interconnected with each other. All right, could we do that with our system? If we take our magic box of 3.1357 inches by 6.1357 inches by 6.1357 inches, and we filled it up with our gallon of water or a gallon of milk, and we put it on a scale, how much would it weigh? Would it weigh a pound?
Absolutely not.
Absolutely not, because it actually weighs 8.3 pounds or 132.8 ounces. Why do we do this to ourselves? And even the pounds, there are 16 ounces to a pound. Something to keep in mind, ladies, that's very important. Another problem with the standard system in the United States is that we have ounces, which is a unit of weight because we're weighing something, which is very different than FLOZ, which is fluid ounces, which is volume. Those are 2 different terms, 2 different unit of measurements, and they are not connected, but it's the same word. Why did we give it the same word? I don't know. It's the stupidest thing I've ever seen in my life, but they're not the same. So you do have to know, are you talking about fluid ounces, which is the amount of liquid, or are you talking about the weight of something like a 4-ounce steak or an 8-ounce steak? That is the weight of it if you put it on a scale. Does that make sense?
Yes.
So we have 1 pound is 16 ounces. Ugh, why do we do this to ourselves? So here is a picture of what I was just explaining. We have fluid ounces and we have weight, which is totally different, right? They're not the same. Here we are measuring the volume of something, and here we're measuring the weight of something. So not the same. All right. Any questions so far? So here are the 3 things that we can measure, right? We can measure distance, we can measure volume, and we can measure weight or our mass. And in the metric system, they are all interconnected with each other. They're all divisible by 10. It's just ones and zeros. Perfect, beautiful, scientific system. And then we have our system, the standard system. That's not really standard of this here. And this is where you will have to know this when you're in the hospital as CNAs, because like I said, one of your tasks will be to measure all of the intake of a patient and the outtake of a patient. When you measure the urine in the bathroom, it's going to be a graduated cylinder in milliliters. But when you get stuff from the kitchen, it'll be a cup of soup or a pint of ice cream or so many fluid ounces of juice, because you'll grab the box of juice and on the side of it, it says 8 fluid ounces, because all of the products made in the United States will be measured using this system. And the products will all say this. So you have to be able to measure these things and then convert them to milliliters for reports. So that's what we're going to practice today. All right. So practicing conversions. Like I said, we cross multiply for a lot of them. So here is our first problem. So we're in the hospital and we had a patient that had 8 fluid ounces of orange juice. They were given a cup of black coffee. They had 2 cups of soup and they ate a pint of ice cream. How much liquid did they bring in altogether? How do we add all this together? Well, the first thing is we have to decide what unit of measurement we're going to put our total in, because these are all different sizes, right? We have our fluid ounces, we have our cups, and we have our pints. Which one of these are we going to use? Are we going
I
to use
would
pints,
convert
cups, or
them all
ounces?
into ounces.
We would put them all into the smallest unit of measurement, which will be ounces. So let's put these all into ounces. So 8 ounces, that one's finished for us already. We know that's 8 fluid ounces. All right, 1 cup. How many ounces is 1 cup of coffee?
8 ounces.
So I have 1 cup is 8. Actually, I don't need to convert that because it was simple. It was a 1. So I'm going to have 1 cup is 8 fluid ounces. How much is 2 cups of soup?
16 ounces. Sorry.
16 cup. Now, if I wanted to show the math for that, I know that 1 cup equals 8 ounces. And I'm trying to figure out 2 cups. So how do I cross multiply? I'm going to take 8 times 2, divide by 1. What is 8 times 2?
16.
Divide by 1 is also 16. So there's my 16 ounces, and that's how I cross multiply. So I have 16 ounces. So the 2 cups of soup was really 16 fluid ounces of soup. And then our 1 pint of ice cream. How do we do that? How many ounces is 1 pint? Well, I know 1 pint is 2 cups. So I have 1 pint, which is 2 cups. And I know, and that 8 ounces is 1 cup. How do I do that? I actually need to go pints to cups to ounces. So how many cups is 1 pint? Pint is going to be 2 cups. And then I need to now go 2 cups to how many ounces? And I know 1 cup is 8 ounces. So I'm going to take my 8 times 2, divide by 1, which is going to be my 16, just like before. 16 ounces. Oof, a lot of work. So how many fluid ounces did the patient take in during this meal?
38.
8, 8, 16, 16.
48.
This is also 16 here. So we have 16 times 3. That's how my brain would do it, is 16 times 3. 3 times 6 is 18. 3, 4, 48. Is that what we got? 8, 8, 16, 16, 48. And the answer is
48 ounces.
48 fluid ounces.
Fluid
Yep.
ounce.
So now we need to change that to milliliters. So how many milliliters is that? I know 1 fluid ounce is 29.5-ish milliliters. So 1 fluid ounce is 29.5 milliliters. Where do I put 48? Do I put it at the top or the bottom?
Top.
Because my fluid ounces are on the top. So there's my fluid ounces. So I'm going to put the 48 fluid ounces up here, and I want to know how many milliliters that is. So now let's cross multiply. 29.5 times 48 divided by 1. What do we got? We would need to use a calculator for that. What's 29.5 times 48? I would grab out my trusty calculator here. 29.5. What did you get, Libby?
1,392.
I got
All right.
116.
I got 1,416 as well. I got 29.5 times 48. Do we all agree? 1,416?
Yes.
All right, so that's 1,416 milliliters, or 1.416 liters. So it's almost 1.5 liters, right? 1.4 liters. So it's almost like 1.5 liters of Coca-Cola. That's how much liquid they took in altogether. How cool is that? So we can easily convert between milliliters to liters. Once we get into the metric system, everything is so much easier. So 1,416 milliliters of liquid. So then we would put that in their chart that their intake was 1,416 milliliters, or about 1.5. And you could estimate and just say, I was about 1.5 liters. About, right? You'd say like about 1.5 liters is what they took in. All right. Any questions about that? Let's look at cross multiplication one more time. So again, like I was saying, our rule is that we multiply and then we divide by the other number. So if I take 12 times 3 and divide by 1, that will equal that bottom number, 36. 12 times 3 is 36. All right, let's do it the other way. What if I didn't know how many feet this was and I was trying to find this answer? What numbers could I use to find how many feet? I know 1 feet is 12 inches, and I'm trying to think how many feet is 36 inches? How could I find that?
Divide by 12.
What number would I divide by 12?
36.
36 divided by 12, exactly, because I'm going to do 1 times 36, 1 times 36, which is 36, and then I'm going to divide by 12, which would give me 3 feet. All right, what about this one here? We're trying to find the 12. We know we have 3 feet, which is 36 inches, and I have 1 foot, and I'm trying to, well, how many inches is 1 foot? How could I do the math there? What do I do? I'm going to cross multiply. What numbers do I multiply?
36 times 1 divided by 3.
Yes, 36 times 1, and then I'm going to divide it by 3. 36 times 1 is 3, divided by 3 is 12. So that's our rule for cross multiplying. And the biggest thing that you need to remember is that you keep the same unit on the top and the bottom. So if we're putting inches on the bottom, we want inches on the bottom. If you're putting feet on the top, you want feet on the top. It'll work either way. The main thing is you just have to make sure they're the same. If you have cups, you're keeping it on the top. Pints, you're keeping it there, and that you're matching them top and bottom. And if that is the case, and if you're missing one of those 4 numbers, you can just cross multiply to find that missing number. All right, let's do some exercises today. Let me pull up our worksheets for today. All right, perfect. Here's our worksheet. All right, first story problem. Can I get a volunteer to read our story problem?
I can.
Go ahead.
A string that is 80 inches long. She cut 3 feet pieces of the string to make necklace. Each necklace will use 1 3-foot piece. How many necklaces can Adela make using this string? 1 foot equals 12 inches.
Yeah. So we know 1 foot equals 12 inches. All right. So she has 80 inches of string. How many feet is that? If it is 80 inches, how many feet is 80 inches? How can I cross multiply? So I have 1 foot, I don't know, 12 inches and 80 inches. How do I cross multiply? What do I do? What math do I put in the calculator?
So 80 divided by 12?
Yep, 80 divided by 12. And what do we get in our calculators?
6.67.
6.67 feet. All right, so that's how many feet she has. And she's cutting them into 3 feet sections. So 3 foot, 3 foot. How many can she make?
2.
2. She can make 2 of them because and then she'll have a little bit left over. Yep, because she'll do 3 and then she'll do 3, which will be 6, and then she'll have 0.6 whatever left over. So she can make 2 of them. Excellent job. All right, here's our next one. Who would like to read this story problem?
I will.
can do it.
Okay, go ahead.
Casey is making an exercise plan. She plans to walk a trail near her home 20 times each month. It takes 40 minutes to walk the trail. If Casey keeps the same pace, how many hours will she spend walking the trail each month? 1 hour equals 60 minutes.
Yep. So it's 40 minutes a time, and she's going to do it 20 times. So how many minutes is she going to walk? What is 40 times 20? How many minutes?
80.
More than
No,
80.
800.
800. There you go. Good job. 800. So there's 800 minutes. And we know that there is, here's my ratio. There are 60 minutes and 1 hour. I need to know how many hours that is. How am I going to cross multiply? What do I do?
You go like there's 60 minutes and 1 hour, so then you would have that, and then the 80 minutes divided by a question.
Yes, very good. So 80, oh, not 80, 800. So we're going to take 800, divide it by 60. So 1 times 800 is 800 divided by 60. What is 800 divided by 60?
I'm getting 13.3.
Yep, that's what I'm getting too. 13.33. So it's going to take a little over, 13 and about a third of an hour. So 13 hours and 20 minutes, more or less. 13.3 hours. Excellent. All right, I think we got 3 more questions. All right, next one. Who would like to read this one?
I can do that.
Okay.
Use what you just learned to solve this problem. Elijah's dog needs 8 ounces of food per day. Elijah buys dog food by the pound. How many pounds of food does Elijah need to buy to feed his dog for 2 weeks?
All right. So there's 2 steps to this problem. First, we need to find out how many ounces he's going to need for 2 weeks because it's every day, right? 8 ounces every day. How many days are in a week? How many days are 2 weeks?
2 weeks is 14
14.
days.
14 days, and it's 8 ounces per day. So how many ounces will he eat in 2 weeks?
112.
112. I didn't put it in my calculator. I will trust you. Do we all agree 112? 112 ounces? That looks right because 10 would be 80, and then we have 4, which is 32. So 80, 90, yeah, 112-ish. Sounds about right. All right, and now we need to know how many pounds that is. We don't know how many pounds, but what's our ratio? What's our ratio? How many ounces is a pound?
16.
All right, where do I put the 16? At the top or the bottom?
The top.
Because it's the ounces. Very good. So 16 ounces. Where do I put the 1? At the bottom, because that's where I'm putting my pounds. And now I need to cross multiply. So 12 times 1. And then we're going to divide that by 16. What do we got? How many pounds would that be?
7.
All right, that sounds about right. 12 divided by 16 is 7 pounds. Yes. All right, number 8. Ladies, this is what I want you to do. I'm going to read number 8, and on your side, I want you to try to solve number 8, and then we will come back together. Something to keep in mind, since this is a fraction, 1/2, we can put that in our calculator as 0.5. It's the same thing. So 4.5 can go into our calculator. That's the same thing as 4.5. So let me read. Mr. Rubin has 4.5 quarts of watercolor paint. His class is making a mural. Each of the 20 students in his class gets 1 cup of paint. Does he have enough paint for all of his students? Think about it. I will give you a few minutes. Go ahead and jot down on a piece of paper and come back with me on what you think. I'll give you a few minutes here. Go ahead. All right, let me know if you're ready. Ready or more time?
More time.
More time? Okay, no worries. And let me know if you're completely stumped and need a hint.
I'm good on this end.
You're good? All right, are we all good, ladies? Let's see what we got. Consensus. Is there enough paint for all the students? Yes or no?
No.
No? Eva, Christina?
No.
No,
No? Why?
there's only 18 cups.
There's only 18 cups. Very good. There are 18 cups. And how did we find that there were 18 cups? What math did we use?
1 cups to 1 quart. And in the problem, half quarts, so we put that on the bottom and tried to find the cups that were in 4.5 quarts.
Okay. So kind of like that there's 1 quart, and now I have 4.5 quarts and 4 cups, and I want to find out how many cups there are. So what math did we use to find it?
We times it.
Yep, we multiplied 4 times 4.5, which is 18. And he has 20 students, and so he's 2 cups short. Poor students. All right, number 10. Oh, sorry, did I say number 10? Number 9. Here's number 9. Who could read number 9 for us?
I'll do it.
Go ahead.
A lemur at a zoo has a mass of 3 kilograms, 630 grams. The zookeeper records the lemur's mass in grams. What will the zookeeper write for the mass of the lemur? Show your work.
We should now, this should be super simple. What do we got? How many grams is that? So 3 kilograms. 3 kilograms is going to be 3,000 grams. So how many grams is the lemur? So we have 3,000 and we have 630.
Okay, 630
grams.
3,630.
3,630 grams. We got it. Excellent job. Perfect. All right, so for homework, ladies, I actually gave you another group of these problems that are just like this, story problems for you to do and try to solve and figure out those conversions. So that's one of our homework assignments. Our next worksheet that we're going to go to is here. Let me pull up our next worksheet. All right. So here's just a conversion table here where we have to convert from pints to, or whatever the unit of measurement, to the other one. So we have to have that chart. We have to go back to our slides and remember what the chart said. So let's go back to, let me find our chart here. Okay. So here's our chart. Right, here's our chart where we have 8 fluid ounces, 1 cups, 2 cups is 1 pint, 2 pints is 1 quart, and 4 quarts is 1 gallon. This we'll actually have to have off to the side when we're doing the rest of these problems here. So I'm going to pull that here off to the side and pull up our questions. So here's our question. Number 1, we got 1 pint. How many cups is 1 pint?
2.
2 cups to pint. Gallon. How many pints are in a gallon?
8. Right?
Is it 8? So 2 is 1 quart, and there's 4 quarts. So 2 times 4 is 8. I agree. All right, how many cups are in a gallon?
16.
16 cups in a gallon. Let's check. I'm going to go back to our slides. So we have 1 cup is in 2. Let's work backwards. So 1 gallon is going to be 4 quarts, and 4 quarts is going to be 8 pints, and 8 pints is going to be 16 cups. So 16 cups will equal 1 gallon of liquid. Next one, number 7, 2 quarts equals how many cups? 2 quarts equals how many cups? So I have 2 quarts equals how many cups? How do I do that?
4.
So 2 quarts equals how many pints?
1.
4 pints. Yep. And so then 4 pints is going to equal how many cups?
8.
8 cups. We got it. All right, so 2 quarts equals 8 cups. All right, one more. How many cups is 3 pints? How many cups is 3 pints?
6.
So we
6.
know 2 cups is 1 pint, and we want to know how many are 3 pints. 3 times 2 is 6. 6 cups. All right, so that's one way that we can do these conversions is actually through math. The other way that we can do them is actually using a converter online. So let me pull up our online converter, which is the best thing ever. All right. So over here, this is like an example of an online converter that I can do length, temperature, area, volume, weight. So we are doing volume. So I'm going to click up here. We're doing volume here. And so our next question, number 11, is 2 gallons equals how many pints? So I want gallons here. So here's gallons, and I want 2 gallons. And I want to go over here and say, all right, how many pints is that? That is 16 pints. All right, next question. Number 13, 3 quarts. How many cups is 3 quarts? Well, let's look over. I'm doing quarts. And I want to know how many pints, how many cups is 3 quarts. And it'll be 3 pints will equal 12 cups. How easy is that? Pretty simple. Using an online converter like that.
Yeah.
Yep. So when you do your homework assignment, I actually have a worksheet for you to do all of these conversions from one unit of measurement to the other. You can use an online converter to actually make those conversions. That because when you are working in the hospital or at a clinic and you're having to do those measurements, they will actually have these tools for you. You will be able to go on the computer and use an online converter so you can just type it in. Okay, they had so many pints of this and so many quarts of this, and you can just turn everything into fluid ounces and say, so let's go back to our example that we did in class already with our patient. So if this is what we were converting here, 8 fluid ounces, 1 cup, 2 cups, and 1 pint, I would just change 1 cup, 2 cups, and 1 pint into fluid ounces. So I would start with cups and say, okay, I'm going cups to fluid ounces, and it was 1 cup of soup, and I'm like, all right, that's 8 fluid ounces, and then it was 2 cups, and that's 16, and then it was a pint of ice cream. So I'm going to put 1 pint of ice cream. Oh, it's another 16, and I'm jotting all of those down. And went, all right, so it's 8, 8, 16, 16. Add those together, that's 48 ounces altogether. And then if I want to know how many gallons that is, I can say, all right, well, they had 48 fluid ounces altogether. that would be 6 cups or 3 pints or 1.5 quarts or about a third of a gallon, 0.37, less than half, about a third of a gallon, a little more than a third of a gallon of liquid. And we can make all of those conversions quick and simple online. All right, so let's look at our homework. So your homework for this week, ladies, is first one of those word problems that there are, I think, 4 or 5 of those word problems that we did in class, where you'll have to read and then think about what math you need to do to solve it and how you can use those ratios and proportions with cross multiplication. And then the other one is a conversion worksheet, just like the one we were looking at. When you do this conversion worksheet, feel free to use an online converter to make it quick and simple, because you need to get used to using that tool that you'll be able to use when you're working there in the hospital or a clinic to make those conversions. I do have a copy of the slides, the presentation slides, and then I have the 2 different ones we were actually just looking at here in class, that if you want more practice and exercise, you could go back to the word problems we just did and then look at the conversion worksheet we were just looking at. So that is your homework assignments for this week. Any questions?